Hello everyone, I am Dr. Durgesh Kumar, Assistant Professor at VIT Vellore. In this lecture, we'll discuss the step-by-step solution for maximum subarray problem using the divide and conquer approach. So let's go ahead. So this is the one of the paper that came in the winter 2024 to 25 in the computer science department at VIT Vellore. Okay. So the question states that given an array consisting of a number following elements -2, -5, 6, -2, 3, -3, 1, 5, -6, find the contiguous non-empty subarray within the array that has maximum sum and return the sum as well as array elements. Implement using the design paradigm and give the optimized algorithm and derive the time complexity. So you can see that first part you need to find the contiguous non-empty subarray within the array along with the maximum sum. Okay. Second part, appropriate design paradigm. You have to implement using the appropriate design paradigm, give the optimized algorithm and derive the time complexity. It means that you are asked with the divide and conquer approach. So what we are going to learn in this video, we are going to see the step-by-step solution for a 10 marks previous year questions, the real question that came into winter 2024-2025 at VIT Vellore. We'll also see what exam evaluator expect for a full marks. Exam evaluator will hardly give the 3 minutes to 15 minutes for checking the script of one paper. So he will visually gaze and will look for the key answers. So if you know what the exam evaluator are looking, you can make them easy, their search path easy, and you can score better marks. Then how to write this question in the exam, because you have a limited time and you have to optimize the maximum marks. So in what order, how to attempt the questions like this in a given time so that you score maximum marks. Lastly, we'll see that what are the possible variations that a question paper setter can do with the same questions in the same topic. What are the constraints of a question paper setter so that with one questions you complete this topic. Okay. So moving forward. So this was the questions given a array consisting of the elements -2, -5, 6, -2, -3, 1, 5, -6. Find the contiguous non-empty subarray that has maximum sum, return the sum, implement using the appropriate design paradigm, give the optimized algorithm and derive the time complexity. So we'll see the first part, the recursion call graph, in which we'll find the contiguous non-empty subarray within the array that has maximum sum. Moving forward, so given this is the array, so I have written the element at the top and index at the bottom. Okay, so there are total 8 elements indexed from 0 to 7 and the elements are -2, -5, 6, -2, -3, 1, 5, -6. So first call will be MSA07. So MS stand for maximum subarray. So MS stand for maximum subarray. So this first call will again call the three function call MSA03. Why? Because low was 0, high is 7. So mid become 3. Low plus high by 2, mid become 3. So it has the another function called MSA03 and MSA47. These are the two recursive call, and third one is non-recursive call MCS. MCS stand for maximum crossing subarray. If you have not seen the concept of this, how this algorithm works, please go to my previous video. I will share the link in the description as well as the comment, and then come back and you will be able to solve it. So after this, we'll continue to break the array into the sub part, that is problem into sub problem recursively like that until we reach the base case. And what is the base case in this case? Base case means low equal to high. It means you have a single element in the array. So again, it will be divided like this. So we are expanding on the left side first. So MSA03, low is 0, high is 3. So 0 plus 3 by 2, that is 3 by 2, that comes as 1. So MSA01, MCS, note that MCS is going in the full range 0 to 3, unlike MSA01 and MSA23. Similarly, this will be again divided into 3 parts, MSA00 and MCSA01, MSA11. I hope this is clear to you. Otherwise, you just pause and review the last slide. It will be clear to you. Going ahead, you will get the call graph like this. and a final call graph like this. So we have all the recursive call here of from range starting from MSA07 going to MSA03, MSA01, MSA11. Now, what are the base case? So this is the base case. And this is the base case. These all are the base case because it has single element. This will be MSA00. This is MSA11. This is MSA22, MSA33, MSA44, MSA55, MSA66, MSA77. So these are the base case. So what MSA00 will return? So this is 0, MSA00. So this will return the single element -2 and the index, low index and high index as 0, 0. Similarly, this MSA11 will return -5. How the MCS will work? So MCS in this range. So it must include the mid and mid plus 1. So we don't have any option to leave any of this element. So the net sum will be -7 and low and high will be 0 and 1. Okay. So then it, and at this stage we'll find the maximum of these three. So we have -2, -5, -7. So maximum of these three becomes the -2. So this will return here the -2. Then we will again do the same thing for the MSA22. So what the MSA22 will return? Is it a base case? Of course, it is a base case. MSA22 is a base case. So MSA22 will return the 6, right? So MSA22 will return the 6, low equal to 2, high equal to 2. Similarly, MSA33 will return the -2 with the low of 3 and high 3. Now, what will the MCS A23 will return? So MCS A23, what will be the return value of MCS A23? So it has to include the mid and it has to include the mid plus 1. So 6 minus 2, it becomes the 4, 2, 3. Now at this stage, we'll take the maximum of all three. So what will be the maximum of 6, 4 and -2? It is of course 6. So in this slide, you can see that it returns the 6 and 2, 2. Okay. Similarly, the MCS A03. So MCS A03, it has to include the mid. It try to extend as much as possible in the left side, but including -2 is going to decrease. So it will not include -2. Now it must take the mid plus 1, so 6, and it will try to extend as much as in the right side, but -2 is again going to decrease. So as a result, it will include only these two elements for MCS A03. So net sum equal to 1, low equal to 1, and high equal to 2. Now at this stage, it will take the maximum of these three elements, maximum of -2, 1, and 6. So that comes as a 6 and low and high as a 2. So this completes the left side call graph. Similarly, we have to process in the right side call graph. So let's start from the base case MSA44. So MSA44 is the single element. So it will return -3 and the low and high is 4, 4. Low index and high index is 4, 4. Similarly, MSA55 is going to return the 1 with the index 5, 5. And MCS A45 is going to return the summation of this -3 and 1. So that is nothing but -2. Now we have to take maximum of these three. Okay, -3, -2, 1. So of course maximum is 1. So it will return 1 and 5, 5. Similarly, we'll calculate the other side. So MSA66 is going to return 5. Okay, it is going to return 5. MSA77 is going to return -6. MCS67 is going to return the sum of these two. That is the -1, 6, 7. We have to take the maximum of these three. So maximum of 5 -1 -6 is 5. So this returns 5. Now we have to calculate MCS A47. So MCS A47. So from here to here. So mid is this. So it must include mid. Is try to take as much as possible in the left side. But taking -3 will decrease the sum. So it will ignore. So it will take up to this only in the left side. Similarly, it must include this mid plus 1. It tried to include as much as in the right side. But again, including -6 will decrease the sum. So it will take only the 1 and 5. So sum is 6. So now the MSA47 will compare the all three 1, 6, 5. So maximum is 6. So it will return 6. Now we have to calculate the MCS A07. So how to calculate MCS A07? So we have to take all the elements. So mid will become 3. So it must include -2, and it has to here it has to process in the left side as much as possible. So taking 6, it increases the sum. Taking -5, it decreases the sum. We'll ignore again -2, it decreases sum. So in the left side, we have the 6 and -2. Okay. In the right side, it must include the -3. It tries to extend as much as possible. So it will extend 1 because it is increasing the sum. It will extend 5. But it will not take -6 because this is decreasing the sum. So this is the subarray that will be selected for MCS A07. 6 -2, 6 -2, -3, 1, 5. So this becomes 5, 1, 6, 6, 6, 12, 12 -2, 10, 10 -3, 7. So as a result, we get 7, 2, 6. So out of 6, 7 and 6, maximum is 7. So this final return from the MSA07 will return the 7, 2, 6. So this is our final solution. So where the net sum is the maximum sum possible from this subarray is 7 and the low index is 2 and high index is 6. So as a result, this will be the input maximum subarray. The output will look like this 7 and 2, 6. So these are the two output and these are the subarray element that is selected. This is the recursion call graph. Okay. So in exam, you have to make only single recursion call graph. You don't have to make a step-by-step procedure. Okay. So this will look like this. A single recursion call will look like this in your notebook. Okay. So after that, you are asked with a algorithm. So this is the max subarray algorithm. This is the base case. You must write the base case. And this is the recursive case where it is having the 3 call and comparison, whichever is the greater, it is returned, followed by the maximum cross subarray function. So that we have already discussed in the last video. So then you have to tell the recurrence relation Tn equal to θ1 plus 2Tn by 2 plus θn plus θ1. So this is for the maximum subarray for the 2 half. That's why 2 and size of each half will be n by 2. θ1 for comparing the base case, θn for the maximum crossing subarray, and θ1 to compare which of the 3 solution is greater. So this is the key recurrence equation. So it can be written like this, and this will be reduced at Tn equal to 2Tn by 2 plus θn, which can be reduced to O n log n using the master theorem second case. So time complexity become n log n, space complexity become order of log n. This is due to the recursive call stack. At any time, the height of the recursive call graph will be log n. That's why the space complexity is log n. Okay. So how to write in exam in the optimal time? So let's see that how the complete solution looks like in a handwritten notes. So in a handwritten note, so this is questions. So I have first written the algorithm because there is nothing to think over there. Okay. So these two functions, maximum subarray and maximum crossing subarray, I've written these two functions. I've written the recurrence relation, the meaning of each term, and solve the recurrence relation using the master theorem. So this is the one part of the question is done. Then the major part of question, I have written the array and I have written the abbreviation of MS and MCS and shown the recursive call graph like this. And at last, my answer is maximum sum equal to 7. And this is the subarray that is selected contributing to this maximum sum. This is how a real answer will look like. Okay, coming back to this. So how to attempt this in the exam for optimal time? So since the algorithm will not take much time, you don't need to do much processing. So my suggestion will be to write the algorithm quickly if you remember. If you don't remember, don't start with algorithm. But if you remember, just write the algorithm quickly. Write the time complexity derivation like just the recurrence relation and mention the master theorem second case. So your time complexity is done. So one part of the question is done. So you will easily score 3 to 4 marks in the minimal time. Then you have to write the recursive call graph and the final answer. So this will take some time, and that's why 6 to 7 marks is allotted here. They may vary and ask also the properties of divide and conquer. If they have asked, you can write this first because this you will be knowing and you don't need to think and the process for this part. And then at last you can write the recursive call graph. Okay, so I have already shown you the handwritten solved answer for your reference. Now going forward, this is the second problem that you should solve, and we'll discuss this solution in the next video. This problem has also come in the winter 2023-24 in A2 slot at VIT Vellore. So define the maximum subarray sum problem. So here it is asking for the problem definition. Formally state the problem. Find the series of contiguous elements that result in maximum subarray sum for the array given below. Array are -2, -3, 1, 4, -1. 3, 5, -4, 6, 1. Write the recurrence relation and time and space complexity. So you can see that how much part is the common in both the questions. All the questions will involve a recursion call graph. It may ask to write the algorithm, time complexity derivation. Optionally, it may ask the properties of divide and conquer. So going forward, what are the evaluator mindset? So like in this question 2, evaluator may give 1 marks to the problem definition. So maximum subarray algorithm or pseudocode, they may give the 4 marks. Recursion call graph in the above instance, they can give 4 marks, and recurrence relation and time complexity 4 marks. So this is the tentative marks distribution. This varies from the evaluator to evaluator, professor to professor, but this is the tentative marks breakdown how the professor evaluate and what are the key component a professor looks in your answer sets. Okay, then what are the possible variations of this question? So the one component that will be always included in this question is the numerical questions for the solving maximum subarray, where you have to show the recursion call graph and actually solve a maximum subarray problem for a given array. Then they may ask the algorithm plus time complexity. They may also ask partially the properties of divide and conquer algorithm, or state formally state the problem. Or they may, if they go very creative, they can ask why divide and conquer is applicable in this case. There is very less chance, but they may ask the correctness proof of the algorithm. They usually avoid that, but these are the possible variations in these questions, in this topic. I hope you are clear with all the possible questions. So what we have learned, we have solved step by step for a given numerical, the previous year paper, using the divide and conquer paradigm. There were 3 cases. Each call to the maximum subarray has the recursive call in the left sub part, right sub part, and the crossing subarray, MCS. So there was MS, MS, and MCS. Then the final answer we got for the previous year question 1 was maximum sum at 7, and this was the subarray. Time complexity is n log n, and space complexity is log n, which is for the recursive call stack. Pro tip: write the algorithm recursion tree and recurrence to secure the full marks. Okay, so thank you everyone. Please share your comment, doubt. Please share and the subscribe. We'll have the more video on the other topic like the Huffman coding in the next video series. Thank you everyone. So I would highly appreciate your questions, suggestions in the comment section. If you like the video, if you like the effort, please let me know through your comments. Like, subscribe, and share this video. Thank you.